welcome back. In this video tutorial we are going to see how to download air quality data, specifically sulfur dioxide data from Google Earth Engine. So this dataset is being given by Sentinel-5P. So let us have a look at the Sentinel-5P. So the Sentinel-5P was launched in the year 2017 and with a planned lifetime of 7 years. It carries the TROPOMI instruments which focuses on atmospheric measurements for air quality, ozone, UV radiation and climate monitoring. So basically the dataset is available from the year 2018 till 2025. It is ongoing, and if you see the measurement unit of sulfur dioxide, it is in moles per square meters, and specifically you can use this band name to get the sulfur dioxide concentration in the atmosphere, and you can see the value range for the sulfur dioxide. So let us move on with the Google Earth Engine. Now you can see here, this is the Earth Engine data catalog for Sentinel-5P. As you know, Sentinel-5P offers a lot about air quality. So in this case we are going to just concentrate on sulfur dioxide. So you can more about the sulfur dioxide. So if you just open it, you can see the description of sulfur dioxide, how it originates, or what are its risk has been given. So if you move on to the bands, you can find number of bands in this, and we are specifically going to focus on SO2 column number density. Please take a note of it. Now let us move on to the script. So you can see here, the first step is to define your area of interest. We can choose it from the shapefile which we have already uploaded to the Google Earth Engine assets, or you can draw a circle from here. If you can draw a rectangle, or you can draw a shape. From that also you can select your area of study. So in this case I am going to use the African boundary. So let me import it to the script. So first we have added our shapefile, right? So defaultly the name is being given as table, and here we are just telling variable. First we are defining the study area. So for that, first we are defining the variable, and I am going to give a name as a geometry. So inside that our shapefile will be available like this. Or for example, if you are interested to draw a polygon or rectangle, you can do so. You can just draw a rectangle like this. You can choose your area of interest using this option. You just need to update it. For example, you can see after drawing the polygon over here at the top, you can find automatically this has been imported. It is called as geometry. So you just need to change the table to geometry to bring on this into an area of interest, right? Now let me delete this one, and we just stick on to the study area boundary, that is Africa. You can have a view of this African boundary and you click on this asset on top of it. So you can see here, you can have a view of this boundary as well. Now let us close it, and we just focus on this loading the Sentinel-5P sulfur dioxide data. So next is I am defining another variable. So here I am defining SO2. So here we need to get the image collection for sulfur dioxide, right? So for that, you can at the top you can find search option. Just type in Sentinel-5P, and you can see here Sentinel-5P offline sulfur dioxide. Just click on it. You can copy the image collection, or you can click on import. It will be directly added like we did it to the shapefile. Okay, after copying it, you can see here I have defined a variable called as SO2. Inside SO2 this collection will be there, sulfur dioxide collection will be there, right? And after that you can see I am using the option filter bounds to filter based on the study area or geometry of which we have selected, right? So here I am importing this geometry because this is our boundary, and followed by that I am using dot filter to filter it by based on the date. So let us put on 2025 May month, right? So the data set is available from the year 2018, keep that in mind. Now after choosing the date range start to end, the next function is we are going to select the band. So as I have already told you, we are going to focus on a specific band which has the sulfur dioxide concentration. So you can see here SO2 column number density, you can just copy it and you can paste it here. Okay, then we have selected the band. After that we are going to use a reduce to one image using mean function, because as you can see here this is a larger area, and covering it, getting the data for the entire region is near to impossible. So because there might be some data gaps, sometimes the instrument might not be taken the image, or it might be due to the cloud coverage. So for that we are going to use the mean function. So once again I am defining a variable called as SO2 mean. So we have already have the SO2 collections from here, and after that I am going to use the function dot mean, right, followed by that. So actually the mean function, what it does is it doesn't stick to one date, it may be taking different dates and combining together to get a result. Okay, right? And after that we are going to use the function called as clip. So we are going to clip the SO2 image based on our study area boundary, that is geometry, right? And followed by that we are going to set the visualization parameters. As you can see here I am defining a new variable called as band vis, nothing but band visualization, and you can see the minimum and maximum value. You can get the minimum and maximum value if you just come down, you can see it here itself, they have given the minimum and maximum value for SO2, right? Fine. After that you can see here I have just given some color scheme to it, and followed by that we are going to add the layer, the sulfur dioxide layer for Africa. So in order to load that we need some couple of functions. For example, first we need to center the map based on the geometry, that is our study area, and after that I am going to specify the zoom level. You can set zoom level based on your need. So I have given 6 because it's a big area. If you can also increase the zoom level to 7, 8, 9, or even reduce it furthermore. Followed by that, in order to add the SO2 map here in the Google Earth Engine visualization part, we are going to use the function map.addLayer, and here we are going to load the SO2 image. So you can see here already we have defined the function SO2 mean, right? So that image we are going to load, and followed by that we are going to use the visualization parameter which we have defined here, right? So that we will be taking into account band vis. Followed by that we are going to give a name to that layer. The layer will be appearing over here. For that we are going to give some name. So this is SO2 mean, I have just given it. Finally you can see here we are going to export the image to Google Drive. So for exporting the image we are going to use this function export.image to drive, and which image? The image is nothing but SO2 mean. As you can see here, this image we are going to export it, and you can give any description for it. For exporting you can give any description for it, and followed by that you can see the scale. So I am giving the scale as 1 kilometers, right? So the native resolution is around 7 kilometers, and if you just check in here you can see the pixel size, it's almost a kilometer, more than a kilometer, right? Okay. And for that I am giving a scale 1000 meters or 1 kilometer, and region. So we are going to export based on the geometry, the study area, right? Africa. So that is why I have defined region. So based on the study area boundary, the output will be exported, SO2 results will be exported, and you can see followed by that maximum pixels. So you can use this, and you can upload, you can just export up to 1 trillion pixels. Finally, the file format I have chosen is GeoTIFF, and after doing this all, you can directly click on run the script. So let us wait for the result to come up. So as I have already told you, this is quite a big area, so right, so there might be some data gaps. You can also increase the date range. For example, you can go up to 1 month in order to get a full composite of this African continent, right? Now we have got the image. As you can see here, the layer SO2 mean, the name which we have given, that you can see here, SO2 mean, right? You can just click on here. If you need to add some colors or change some colors, you can click and change the colors, or you can also reduce the number of colors which is being shown. Okay, right? You can also hide the image like this. You can hide the image, right? So based on the color scheme itself, you can find the area of higher concentration of SO2. So red is the highest level. If you use the inspector tool, you can easily read the values. You can see here it is 0.08, and if you just compare it with this, it is very high, right? Okay, now in order to export this image, we are going to go on to the taskbar. After a running script, go to taskbar, and you can see SO2 Sentinel-5P export, right? Now click on run. Some things will be asked. So you can see here, this is the task name which we have given. From here itself you can identify the task name, and followed by that, you can see if you want, you can change the coordinate reference system and pixel size. Okay, right? And after that, we are going to give a folder name. So in the Google Drive, I have created a folder called as GEE. You can create any folder. You just need to specify the name, folder name, so that automatically the exported image will be saved there. Okay, right? So this is the file name. Now let us run the script. So after clicking on run, you can see a page. After a few seconds, it will be appearing like this. You can check in the progress of export. So it is telling me it's less than 1 minute. So let us wait for it. So the image has been exported. Once it has been exported, let us view it in Drive. So you can see the image over here. We can download the image. Let us see what is the size. So it is around 282 MB, as it's a big area, right? So let us download it and visualize it in JS platform. So the image has been successfully downloaded. Let us view it. So you can see the image. So before importing the image, let us go to the properties and edit the no value data, so that we won't be getting any background values in black color. So apply, click OK. Now let us add the image. So you can see here how the image looks like. You can change the color scheme for it. From here you can pick any color. So I'm going to just change the color scheme over here. So the light blue is low, and the pink color, as you can see, that is the high value. You can see here, you can see the difference, right? So I think there might be some volcanic activity, so that's why this area is like that. And still you can see some data gaps over here, right? No, it's fine. Yes. Now if you like this video, please give us a like and subscribe to the channel. So thanks for watching. If you found the video useful, please do share it with your friends. Thank you. Goodbye.